Cheap green power decides whether Europe wins or loses the next decade. That's one of the conclusions of my book, Transition Science in the Economy, published last year. And in this episode, I thought I would show you why. This episode is not about climate slogans. We had enough of those. Uh, it's about something much more concrete. Why the digital transition, the green transition, the transition to a war economy, or the transition to a new globalization, all break at the same point, all depend on one the same thing, energy costs. And here's the uncomfortable truth. Europe can talk about AI, defense, resilience, industrial policy, but without cheap green power, none of these scales, none of these flies. That's the promise of this episode. I'll show you how energy costs quietly shape research agendas, innovation outcomes, and funding decisions. First, I'll look at the why, and then I'll show you two real cases. And in the end, I'll give you two concrete actions you can apply immediately for your research or proposal work. So, if you care about not betting on the wrong future, the wrong horse, this episode is for you. And if you want the full framework behind this thinking, you can find it in the transition science in the economy. Okay, let's start. This episode of InnovEU, the EU Project Chronicles, is brought to you by my new book, Transition Science in the Economy. In it, I use data from more than 180 countries and 150,000 observations, data points, to show how five global shifts, five global transitions, the digital, the green, the new globalization, the transition to a war economy, and the housing crisis transition, how these five transitions are collapsing the middle class and rewriting prosperity and power. So if you want a clear map of today's economy and economic chaos, search for Transition Science in the Economy on Amazon and get your copy. So let's now look at the importance of cheap green power. And I want to be clear, the digital transition and the green transition that the European Commission talks about every day, none of those are possible without cheap green power. Not slower, not harder, not partially. That's not the issue. It's not possible. Digital systems are energy systems, as we can see with the data centers. Data, AI, cloud, semiconductors, connectivity, automation, all of these scales on what? Electricity. If electricity is expensive or volatile, digital ambition collapses. So the same applies to the green transition itself. Electrification, hydrogen, heat pumps, storage, clean industry, they only scale when energy is abundant and cheap. Going green means abandoning fossil fuel, not adding a second layer. Now, look at the third transition, the transition to a war economy. Let's look at European defense. Europe cannot sustain a credible defense posture while being energy dependent. A war economy requires predictable, secure, and scalable energy supply. Energy dependence is a strategic vulnerability. Energy independence is defense capability. So, energy independence at scale is only achievable with cheap green power. Not There's no other way with the present technology. Hopefully, the future will bring other technologies. But until we can count on nuclear fusion, there's no other way. Now, let's look at the fourth transition, the transition to new globalization. Resilient supply chains require more than just trade agreements. They require control over the energy that is embedded in production. As long as Europe depends on Russian gas or imported fossil fuels, which are priced globally, supply chains will remain fragile. Replacing the Putin dependency with a Trump dependency does not solve a problem. It may even bring new problems. So, okay, secure value chains only become viable when energy is locally produced, abundant, cheap, which again brings us to the same point: green, cheap green power. That's the common denominator. Digital transition, green transition, war economy, new globalization, they all depend on this. One could even argue about the importance of cheap green power not being a sectoral issue. It's a strategic foundation for Europe. With that framing in place, let's step back and look at the deeper level. The core idea, my core idea here is simple. Energy is not just an input. It is a system level constraint. Historically, every major wave of innovation has been underpinned by some structural drop in energy costs. Coal enabled the first industrial revolution, then oil enabled mass production and global logistics, then electricity enabled automation and modern science. Renewables do the same with one crucial difference. They also decouple energy from geopolitics. If you produce the energy locally, you're not that dependent on geopolitics. Once solar, wind, hydro, and storage are deployed, marginal costs will collapse. No fuel imports, no price shocks, no strategic choke points. For research systems, this matters more than is usually acknowledged. With high energy cost, research goes for incremental efficiency gains. Sorry. When you have low energy cost, you can go for exploratory research. This is why cheap green power acts as an innovation multiplier, not because it is green or pink or whatever color, but because it removes a constraint, a binding constraint. Now, let's look at this thing we call innovation economics. Innovation output is a function of three interacting variables: energy costs, capital costs, risk tolerance. When energy costs fall structurally, capital requirements fall too. That reduces risk. Lower risk expands the space of fundable ideas. This is exactly what we are starting to see in regions with sustained renewable overcapacity. Data centers will look to that, will shift to their location there. Electro-intensive research becomes viable. Hydrogen pilots move from theory to demonstration. AI training costs flatten. In other words, cheap green power reshapes the innovation frontier. Now, look at this from another angle, from the funding side. Public innovation funding does not reward brilliance. It rewards credibility and uncertainty, because uncertainty is the main variable here. Funding agencies ask a very simple question: can this project survive? Can it survive shocks? We all can promise impact. We all do in our proposals. Will that impact survive? Well, energy volatility is one of the biggest hidden risks in proposal evaluation. Projects that are anchored in high cost or fossil dependent energy, they implicitly score worse on scalability, replicability, and long-term impact. Cheap green power quietly improves all those three. This is why EU funding priorities are shifting, should shift, and are shifting, not rhetorically, but structurally. Calls increasingly assume access to affordable renewable energy has a baseline condition. It is no longer a bonus. It is infrastructure. It is required. And actually here, you also have a strategic layer. Countries that lock in cheap green power are not just decarbonizing, they're buying optionality. They have optionality for future industries, for optionality for research sovereignty. They have optionality for innovation uh, and funding absorption. This explains why no one's talking about climate ambition anymore. Everything is about energy costs. Whoever controls the lowest stable energy costs controls everything. Drill, baby, drill, some say. Others build renewables, uh, buttloads without much advertising. This is the key theoretical shift that is changing our world and changing different parts of the world in different directions. Cheap green power is not an environmental policy. It's an innovation policy. It's a research policy. It's a funding strategy. Once you see this, many puzzles disappear. Why do some regions attract Horizon Europe pilots repeatedly? Why certain universities dominate energy-intensive research fields? Why some proposals feel future-proof while others feel fragile? They are built on different energy assumptions. And energy assumptions are destiny. So in the next section, I'll show you how this theory plays out in practice in two concrete cases. Okay, so I want to walk you through two concrete cases, not really success stories, not in the marketing sense, but structural examples of what changes when cheap green power becomes available. So the first case study, it's a research team I know over the last decade. Data and AI research has become massively energy intensive, training large models, running simulations, operating high performance computing clusters. In theory, this research is footloose. In practice, it's not. It follows electricity. Regions with high electricity prices will see this kind of research remain small, fragmented, grant dependent. Regions with cheap, stable, renewable power will have better chances of seeing it scale up. This is why we observe silent relocations of data centers, AI labs, computational research toward regions with renewable overcapacity. Nordic countries can be a good example with abundant hydro and wind, stable grids, predictable prices. So, what changes is not just the cost, it's research behavior. Projects will look safer in these places because the energy risk is removed from the equation. This team I know has been getting better evaluations in their proposals after they moved. Case study 2, hydrogen and industrial innovation. This is a different domain, hydrogen. For years, hydrogen was a PowerPoint technology. I have to say I'm fascinated by this field. It's technically elegant, economically impossible. The bottleneck was never chemistry, it's always electricity. Green hydrogen only works when renewable electricity is both abundant and cheap. So in regions where renewable overcapacity exists, energy projects can move from strategy papers to pilots. Electrolyzers run continuously and industrial users can test real substitution of fossil fuels. And this then has a cascade effect. So there's a hidden pattern here in these two cases. They both share this same hidden driver, cheap green power. Three words that, okay, does not guarantee success, but it removes the main reason for failure. And it turns innovation from a bet into a process. And this is the bridge to your work. If your research, your innovation project or proposal implicitly assumes that expensive or volatile energy will be used, you are carrying a silent penalty. If it assumes cheap, stable, renewable energy, you are increasing the credibility for the system. So the next section, I will translate this into very short, concrete actions you can apply immediately in your research or in your proposal work. So what's the task? Most projects fail silently at the assumption level, at the very beginning. Energy assumptions are usually implicit, which means they are not examined. Your first task is simple. Take your current project or proposal and answer one question clearly. What energy would what energy world does this project assume? High cost and volatile, or cheap, stable, renewable? Then make that assumption explicit. Write it down. Name it. Anchor it geographically. Link it to the infrastructure. This does two things. First, it forces you to see whether your project is structurally fragile. Second, it signals awareness to evaluators. You're showing them you know what lies behind your project, what are your assumptions. Awareness reduces perceived risk. So that's your task for this week. I hope you enjoyed the episode.